Okay, today we are going to learn how to use the calculator in order to find out the order of a reaction. So this is another method. So we've learned one method, and that was when we repeat an experiment several times, we can compare the different reactions by putting like experiment 2 over experiment 1, making a change in concentration. So this is different because we're just looking at one experiment and we're watching the amount change. And so the amount could be in molarity, it could be in grams, it could be in percent. So we're going to be watching the molarity change over time, and we're going to be graphing the information to determine whether it's zero order, first order, or second order. We won't be looking at any higher orders than those. And so the first thing you need to do, and then of course I've printed off, and I think I made a pretty good step-by-step worksheet for this, so hopefully you can follow along with it. But in the example, we're just going to do sample 1 on the video, because if you can do one, you should be able to do them all, and they're pretty easy. You need to make sure that your calculator catalog or diagnostic is on, and so you're going to hit, and if you leave it on, and once it's on, it'll stay on. You're just going to hit second and catalog, and then the alpha is already activated, so we can hit the D, and you can see the D in the background, and we can hit D. We can just scroll down until we find the diagnostic, and we want to turn it on. So then you just want to hit enter, and then enter again, and it's done. So it won't turn off again as long as you don't mess with it. Alright, so we're going to input our data, and we're going to put our data into the stat, and you're going to edit. And then you should see L1, L2, L3, and L4, the ones that we're going to be dealing with. If by chance you've deleted one of those, you can always insert it back in. In your L1, you're always going to type in the time. L1 will be where we put time at all points. So our first one we're doing is 0, and we should just be able to enter that, and then 50, 100, 200, 300. Alright, so our time is always in our L1, and in our L2, I'm going to have to move it over. Okay, we're going to always put the amount. So our amount, again, could be in molarity. Our example 2 is in torrs. So we're going to type in the amount. So just give me a second to get this information input. Alright, so in L1 is our time, and L2 is our concentration. In this case, it's molarity. Alright, so if we were to graph just the L1 and L2, or I should say L2 versus L1, that is the amount versus time. If I graph that and it makes a straight line, this would be a zero order reaction. And before the calculators got fancy, well, a long time ago, everything had to be hand plotted. But we used to have to do these one at a time. But these nice calculators can go a little bit further, so we're going to now go into L3. And what we want to do in L3 is we want to take the natural log of this, because we're going to be testing for first order. And so if you come up and highlight the L3, and once it's highlighted, you can then simply click the LN button. So now it's ready to take the natural log, and you're telling it what to take the natural log of it. And we want to take the natural log of L2. So we're simply then going to, you can see L2 is in the background here in yellow. On this calculator, you're going to go second, 2. And that's going to now, if you just hit enter, you don't even have to close the parenthesis. It will quickly take the natural log of that entire column for you. So in L3 right now, we have the natural log of the amount. And then over in L4, we're going to be testing for the second order. And the way we do that, if you remember the half-life equations, second order had 1 over the amount. So we're going to take 1 divided by the amount, and again we put the amount in L2. So we're going to hit second, 2 to make the L2 show up and hit enter. Alright, so now we've taken 1 over the concentration in an L4. So L1 is time, L2 is the amount, L3 is the natural log of the amount, and in L4 we've got 1 over the amount. So now we're going to graph it. Before you begin, because of your math classes, you're going to want to make sure your y equals is empty, because if you've got stuff in your y equals, the calculator will be graphing that information. So clear that out. And then you're going to turn your stat plot on. So we're going to go second, y equals, and you can see my stat plot is off, so I'm going to hit enter. And you're going to select it. A little harder to do on the computer here. And then the actual line graph itself is the one we want to be able to choose. So we're going to come over and pick that one. And the first thing we're going to do is to check, and we're going to test for the zero order. The zero order is the amount should be on your y-axis, and the time should be on your x-axis. So we put time in L1, we put the amount in L2. So right now it's defaulting to that, so we're just going to now hit graph. If you don't see it, and most of the time you won't because of where you've been doing, you're going to hit zoom and then 9. Whoops, zoom 9. If you go scrolling down, you'll see number 9 is a zoom stat, and so zoom 9 will make the graph it for you. And you're looking to see if this is a linear line, and it is not, so we know it has just failed the zero order test. So now we're going to go back to our stat plot. We're going to change, and we're going to change our y. We want it to be L3 now, because we're going to test it for first order, which is the natural log, and we put the natural log in L3. So now we're going to, we've changed it, we're going to hit graph. We can't see it, so we're going to hit zoom 9, and that's getting close, but there is a little bit of not straightness right here, and we're going to be able to look and see in a moment when we do the slope how close this is to a straight line. But it's closer, but it's still not first order. So now we're going to test for second order. Obviously it's second order if it failed the other two tests, but we still want to graph it to be able to draw it and label our axis, etc. So we're going to now hit our second step plot. We are now going to change. Keep wanting to hit the computer buttons and not the calculator's buttons. And so you want to go second, and we want to change it to L4, because in L4 we put 1 over the amount, so we're about to graph 1 over the amount, and again it should be making a straight line for us. We're going to hit graph. We don't see it, so we're going to zoom 9, and that is a straight line, really close to a straight line, closer than the other one. So then at this point you would draw what you see, and it doesn't have to be perfect. You would label your x and y axis. On this particular one, your x-axis would be labeled time, and then you would label the unit, which is seconds, and then you would label your y, and this one was 1 over molarity, because the molarity was what we tested in this particular graph to get our straight line. Now to find our k. Our k is actually the positive value of our slope, so we need to find our slope. So we find our slope by going back to stat, and we move it over to calculate, and we want a linear regression because we are making a straight line, so we're going to go down to 4 and hit enter. Oh, and this is an old calculator. Your new calculator, see, the only thing I could do to get an online version was the 83. But this is good, because if you have an 83, this is a good way for me to show you how to do this one. But most of you probably have an 84, and the 84 has a place for you to put what's in your x and what's in your y. And then, so at that point, you want what made the straight line, and your straight line was L1 and L4, so you want to change it to L4, and then you want to move it down to calculate and hit enter. So if you have an older calculator like this one, so this is good for me to be able to show you this. This calculator right now will default to L1 and L2. Well, I don't want it to default to L1 and L2, so I have to hit parentheses, and I have to tell it which two to choose. And I want it to choose L1, if I could quit hitting that other button, and then I want it to choose, I think, then I have to hit comma. I haven't used the old one in a long time. And then I want to hit L4 was the one on here. And so I'm going to close that up. So I've told it specifically where I want that linear regression. You only have to do this on the older calculators, an 83 and older calculator. And that's the only thing I could find for online. That was free, by the way. So I'm going to hit enter. And once I hit enter, and you guys with the newer calculators just go down and hit calculate, we all should be seeing the same thing now. And so our A is our slope of the line, but not only is our slope the positive, because sometimes we'll get a negative, so be careful with that. Your K will always be the positive value of the slope. So if your slope's negative, still just use the positive number. And so our K is 0.543. So that is our constant for this reaction. And this we said was second order, so it's going to be 0.543, and the unit would be molarity to the -1 and seconds to the -1. And I wanted to point out, and then once now that we know that it's second order, we could actually go to our equations and we could use the second order equation. We could plug in for half-life, and so we would do that 1 over K times the original amount, and the original amount was 0.01, and we would determine that the half-life of this is 184 seconds, and that would have been C. And then to write the rate law, you would just write rate equals, and then you would write your K, 0.543, molarity to the -1, seconds to the -1, and then it would be NO2 to the second power. So to answer all those questions. Unfortunately, while this calculator is up, I'm not able to really do any writing over to the side. But I want to point out the R. The R lets us know how close we are to a straight line. The closer you are to 1, the closer you are to a straight line. So honestly, you don't really have to graph every one. You could just go in and calculate and see which one's closest to 1. But you are going to have to end up graphing them, so to me it's just as easy just to hit the graph and find out which one is the closest. So hopefully this makes sense to you. Again, in L1 is your time, L2 is your amount, L3 is your natural log of your amount, and L4 is 1 over. And then you're just going to graph and see which one makes a straight line. So I'm not going to do the second example. Hopefully you did that in class. So I have uploaded the note page and the homework page, and I should get the homework page answers up soon as well. So have a good day.